Hello, today we are going to learn something about gradient descent. For this, I picked the neat code problem, and so let's continue with this. Let's see what a gradient descent actually is. Before that, we have to know a few things. What's differentiation and what's integration? So, let's say we are doing some sort of experiment. If we want to find how many errors we can make, the margin of error at that point of iterations, we can use differentiation. And if it is about integration, if we want to find the volume or the time taken for that experiment, we can use integration. So what differentiation does is we split some shape into tiny pieces so that we can find the margin of the error. In integration, using these tiny pieces, we'll we'll make the shape out of it. So let's see what gradient descent is, and it is a optimization algorithm or a technique that is used in machine learning. Let's say we are on a hill. Let's say there is a mountain here, and we don't know which point we are in. Let's call this model, and we need to find a way so that we can reach the bottom of it with as less errors as possible. And the end goal is not to find the zero of it. That means we are cheating. We need to find the global minimum. That means the maximum value we can find without doing any errors or going to a constant absolute value. So for this, we'll take the current value. Let's call it x new, and so we need to take the old value as reference to continue. Let's call that x o. So to find the current position of it as we are going downhill, we'll subtract the value, and let's say we define something here called learning rate. That means how fast can I move. I give a value like 0.01, 0.1. So with how much learning rate I can move downwards, so that the ML model learns faster. So that's the thing here. That's the learning rate. And as we have talked about differentiation, so everything is a function. Let's say we have a circle. It can be defined as a function. So we will have an imaginary value. So the function here is to get downhill, and so we need to make it. I mean, we need to get the tiny pieces out of this function. So we apply derivation. Let's say our function value is x square. So the derivative value for this is 2x. So we are going to multiply this with 2x, and that should be the old value. So that will be 2x0. So using this, we can find the global minimum, And one thing to remember, going downwards isn't like we are doing something wrong. We are finding a way to do less mistakes. There is another thing called gradient descent. In this, we go uphill instead of going downhill, which is mostly used in probabilistic models like Bayesian networks, all that. But here the thing is this. So naturally, what we see gradients as like this, but we have to visualize this in a 3D way. It looks like a well. So we have learned something called slope in our high school days. This is called a slope. If it is in 3D, then it is a gradient, and descent means going down, ascent means going up. Dis So descending order, and ascent, ASC. So this is an important linear model. I mean, this is an important way to train algorithms, and it is quite popular in neat code learning module. We can find this. So I told you this is a 3D model. This is the initial value. This is the new value after learning something. That will be the third value, fourth value, and this is the formula. The new value is equal to the old value minus the alpha, where we can learn things into, I mean, multiplied by the derivative of the old value. And here we can find a good example for this. See, that's how it looks in a 3D representation. So just to keep things straight, let's write some code here. So according to the formula, it is this x equal to x minus learning rate into f dash x, and we have the initial value in it. So let's keep the minimizer, or r, let's call it r, as init, and let's iterate through the iterations, and here we need to define the derivative of it. So x square's derivative is 2 into x, that will be r, the old value, and r will be the new value, r minus, and we need the learning rate into the derivative, and we'll return the rounded value of this up to 5 decimals. Let's try running this. Okay, it's round. Sorry, my bad. Let's run it again. Yeah. So this is the simple walkthrough of this, and in the next videos we will go through other implementations, other optimization models. So thank you for watching.